All right, stoichiometry. There's our nice little graphic. How to compare two different materials using the mole ratio from the balanced equation. Are you perfect? All right, notice you have a balanced chemical equation. The coefficients in the balanced equation can either stand for simple molecules, right? This says 2 molecules of H2 and 1 molecule of O2 make 2 molecules of H2O. Or we can scale up, basically, and it means 2 moles of hydrogen react with 1 mole of O2 to make 2 moles of water. Right? If we look at the law of conservation of mass, are molecules or moles conserved in a chemical reaction?
Yes.
Are molecules conserved in a chemical reaction? Meaning what? What does that mean? Law of conservation of mass says that if I have so much mass on the reactant side, I have to have the same mass on the other side, right? Do I have to have the same number of molecules on one side as the other side?
No, because there's
Do
3
I
on
there?
one side and there's 2 on the other.
That's right. There's 3 on this side, on the reactant side, and there's 2 on the other. Right? So molecules are not conserved. Mass is conserved. If I add 4 plus 32, what do I get? 36. But what about atoms? Are atoms conserved?
Yeah.
Yeah. Why are atoms conserved?
Because you can't get rid of them.
Because you balance the equation based on that, right? That's the whole reason you balance equations, is that you have 4 H's over here, you have 4 H's over here, you have 2 O's over here, you have 2 O's over there, right? So mass is conserved, atoms are conserved, molecules and moles are not. So you don't have to have the same number of moles on each side. But they do show the relationship between each substance. So it's like your recipe, right? The reactants are your ingredients. The products are whatever you get at the end. So if we're baking a cake, right? If we take 2 of these plus 1 of those, we get 2 cakes. I don't know, right? Or 2 cookies. All right, so it shows you the relationship between the substances. That's what makes it stoichiometry. All right, here's my simple 4 steps to doing all stoichiometry problems. You have to have a balanced equation. So you have to write and balance a chemical equation. That's what you just said for the do now, right? You said it was stoichiometry. Don't I always have to have yes, you always have to have a balanced equation. So somehow you've got to get that information. Then you convert whatever they give you to moles. So whatever your given substance is, they'll give you an amount. Change it to moles. Then you use the mole ratio from the balanced equation, which are those coefficients in the front, right? These are your coefficients from your balanced equation to change substances. Then you're in moles of whatever you were looking for, and you might need to find grams. So you're going to convert that unit to whatever unit they asked for in the problem. Okay, that's all that work that y'all did last year for stoichiometry. That's it summed up in 4 steps, yes? Yeah, and it doesn't matter if you start with grams, doesn't matter if you start with liters, doesn't matter if you start with molarity. Whatever you're given, you're going to change it to moles. But you know how to get to moles from all of those different things, right? Okay. All right, so here's a simple one. I bet everybody can do that one. Do that one on your paper. One gram of glucose. And then they want to know how many grams of water. All right, you see if you can get grams of glucose to moles of glucose. That's what you're going to do first. All right, let's see if we can. Grams of that C6H12O6 to moles. How do you go from grams to moles? I forgot to.
Wait, so it's already balanced?
It is already balanced, so you don't have to do any of that.
Do we have to write down the solid?
No, you don't have to write states of matter. They're not going to matter for your math. All right, grams to moles. How do we get from grams to moles? Stopping and finding answers. Stop.
You can't keep going.
Yes, you can. You're gonna get frustrated if you keep stopping and finding answers because your answers are gonna get way off.
Is this kind of like a test question, kind of? Like
This one's
very
the last
simple.
year. This is the last year test question.
Dang it.
Is the test different this year or good? I can do it.
Well, I mean, some of these will be on there. Just there'll be some harder ones too. This I would consider a basic question for the test.
Hashtag basic.
I'm scared that like I'm gonna think too much on the easy ones than on the test.
Oh well, yeah, don't too much on the easy. There will be some. There's more easy ones on this test than the test later in the year. There are. There are. Don't forget to multiply times their subscripts. So this is 6 times 6. And this is 6 times 16. We're not just adding up those numbers, we're adding up, where's your periodic table? We're adding up the weights. Yeah, there you go. So we need 6 times the mass of carbon. So times 6 times 12, not 6 times 12. So this for carbon is going to be 6 times 12. 1, and then 6 times 16. Then add it up. But at least you knew what to do. That's good. That's good. Okay. All right, this one we got, right? For the most part. Not done yet?
I love doing these types of questions.
You like these?
No, I don't know. They feel like
You feel like you've
Fun.
accomplished something. You've
no,
accomplished
like just like stoichiometry. Like I like the steps. I don't know. Like,
It's cool.
yeah. It's like
So
weird.
it's
It's
really cool.
it's all fun and games. You can't.
And it's like relatively
You can't figure out where to start.
Yeah.
That's the nightmare. Is where if you can figure out where to start in the problems, you'll be fine.
As long
That's
as
why
your
I struggle with
equation
that.
is
That's
balanced.
right.
As long as your equation is
As long as
balanced.
your equation is balanced.
Because I had problems last year where it's like the equation wouldn't be fully balanced, so my entire like answer was wrong. Oh, I never put down the word of the day.
All right, so grams to moles. What'd you get for your molar mass for glucose?
180.
180. All right, so that'll give us moles. Now we're ready to change substances, so we need the mole ratio from the balanced equation. So for every, what's the understood number in front of that? 1. So for every 1 mole of glucose, how many, what are we looking for? Oh, water. We're looking for water. So there's 6 moles of water. And then we have to convert to what units they wanted, and they wanted grams. So for every mole of water, there are 18 grams of water. Good? And you came out with somewhere around 0.6 grams of water. Perfect. All right. This one's a little bit harder. Why is this one harder?
Long.
Paragraph.
Oh,
It's
it
a
doesn't give you
paragraph.
the equation.
It doesn't give you the equation. Okay, don't try to copy this problem or we'll take forever.
No,
Just write the balanced equation from that. Do not write all those words down because you have it on video. You try to write a balanced equation from that. Yes, let me check your, yes. Nope, not quite. We have to go from what you're given. That's what was in the problem, right? And then you use what you did here. I think great, so I want grams on the bottom. That's it. We don't need this one because we're not going to particles. We only need to go from grams to moles. So you're done. All right, so do the math there. And then what you're going to end up doing, your homework's going to be different than
Wait, carbonate CO3, right?
Yes, yeah,
Yes, with what charge?
Negative two.
Negative 2.
Carbonate.
I've got to learn those. Like,
Oh, I was doing. I'm an idiot. Give me 8 minutes.
Alright, your homework is going to be. I'm not standing in your way, Mark. Alright, we're gonna let you do 4 through 7. Now the molarity, this is what we see.
Remember the first.
I don't think I put molarity on your list, did I? I don't think I put molarity on your list. So we won't worry about that. Alright, so 4 through 7 on page 61, that's your. Okay.
Where do we get the lithium from?
What?
Oh, so
Those
they
in air?
Uh-huh.
You know, it's the lithium and it's like that drops that reactor. But it's gonna go.
Oh,
okay.
Yeah. I wonder, you know what, are you having trouble with that setup?
Oh, it's the lithium hydroxide.
That's
Oh,
what
it's
it's
the
called.
hydroxide from the lithium hydroxide.
Yeah. So balancing it is real dumb.
Well, and that depends on.
Wait,
if
so
you're
it's
going
LiOH
to
plus.
particles,
Wait, no.
but
Yeah.
I'm wondering if you're having trouble
Wait, what? I didn't-
LiOH plus CO2 yields
the
Li2 CO3 plus H2O.
not just
Yes.
It threw me off.
not
It
just
threw me
the
off
It
not
does.
saying it.
Let me see if I can find it's
Yeah, balance.
you know what? Let's do this. Let me shorten that. Let me
What do you always balance?
probably just to understand these.
Balance whoever you have the stuff.
I think you might be having
From
more
whatever
trouble.
you
This
believe.
Okay.
setup is the same thing, that when the lines go down, that's where I write my
3, 4. Oh, really? Because I have 3 on.
Okay, so you could have interpreted mine to be.
We need your attendance.
I know,
Oh, yeah, delivery.
Oh, yeah.
People, those crucibles.
It's all books too, isn't it?
I want you some stuff in
But yeah, here's what I want you to do. I want you to shove the desks out of your way and go put them on one of those tables in the back. And I need to figure out what kind of books they are and then deliver them.
They don't
to
feel
those
like
tables.
books, are they?
They don't feel like books?
Yeah.
No, they didn't feel like
What did you order?
I didn't order, it better be books or I.
Maybe
or I
someone
want
sent you
to
a
hear
gift.
it. Open one of those boxes with the arrows on them and see if they're books, they're teacher stuff. Yeah, open one of those and tell me what. I don't know, because if it's engineering, it's got to go to a different room. I'm gonna make those kids do it.
Oh, it's balanced.
It's I lay my pen down over there?
You should too.
Oh, I did. Okay.
One with the arrows?
Yeah, open one of those flat boxes. Open one of those and see what it is.
How many grams?
Why? Let's, okay.
Yeah,
I'm
they are.
gonna change it up. Let's
Yes, they are.
do, I'm gonna have.
You guys are getting new books.
Yeah, that's what I thought. Okay, so they're in the right place. So we can just stack them right there. All right, we're gonna do page 45.
Balance.
And we're gonna do 2 through 6. And then you're gonna do, we won't do all of those. Then let's do, we'll just do A
It's been
and
with
B.
never
We'll
difference.
do 4 through 7, but just do A and B on each one. Like you don't need to do all of them. Okay? Alright, that'll be your. Thank you guys.
How do you know which colleges would
Like take it. There's a place online. I'll show you.
What?
Okay. Alright, ready for me to write it out? No, not yet? Okay. Alright, thanks.
They're both on the same side.
Yeah, I don't get that. Wait, I think
Solid lithium hydroxide is used in space vehicles to remove carbon dioxide by gas inhale. The hydroxide reacts with the carbon dioxide to form lithium carbonate and water. How many grams of carbon dioxide? Oh, what did I
Where'd
do?
it go?
Like, where'd it go? Oh goodness.
That's all that class. Wait, says that.
Shh, I'm listening.
She's not teaching.
She is.
I was pushing buttons. All right, so how many grams of carbon dioxide can be absorbed from 1
No, you have to balance it.
gram of lithium hydroxide? Okay. All right. Oops, CO2. All right, so yes, we need to balance it. So we need a 2 there,
That's it.
and that's it. 2, 4, 2, 4. Yep, that's it. Okay. So what is your complaint?
Like when you do the multiple ratio.
Is
Uh-huh.
it okay that they're on the same side?
Sure.
Okay.
The multiple ratio.
Wait, let me finish then.
Okay.
Pause then.
You don't like it because it's one reactant going to another reactant. That's
It's
what
not
you don't
going
like.
From side to
Yeah,
side.
it doesn't have to. It just happened to be that that's all you did last year.
Imagine that.
It doesn't have to. Because those coefficients are the relationships between anything. If I'm cooking and I need 2 lithium hydroxides and 1 carbon dioxide, if I have I don't know, 3 carbon dioxides, then I'm gonna need 6 lithium hydroxides, right? Like if it was tablespoons of butter or whatever. I mean, right? It's the same thing. So the relationship is just, you can go from anything to anything in the balance equation.
Miss Bennett made this do self-geometry last year. She turned the periodic table into a recipe for like cookies or something.
Mhm.
That's
my
how I
God.
teach it like
She made
that.
us go from
Wait.
like this much
What'd you
butter
get?
to like this
Wait,
much
Flour.
eggs
Yeah.
or whatever. And I was like, Miss
I didn't
Bennett,
hear
what
what
are you
you said.
doing?
I
Wait,
teach it that way. When I teach regular chem, I teach it that way. I do. Because the recipes make sense to you.
Well, I'm not good at
No,
cooking,
they
so
don't.
I
They didn't though. I was like, I don't.
How do you know when to use CO2? Like,
Is this
how do you know
24?
when to use 2 oxygens or just 1? That's what throws me off.
Because there's the formula.
I know, but like for the
Not CO.
Y'all are so mean to each other. How do you 3 stand each other for very long?
us 3,
They are so mean to each other.
like CO2,
I
like
mean, people could say the same thing
CO2.
though.
C.
Type it in one time.
Oh, type it in twice. Like, what is that computer?
I did that, but she got 28. Well, I got 44. I got 44.
I mean, I got 20. Wait.
16 plus 12.
Okay, like CO2, would I do 2 of 16 or
Yes.
just 1 of 16?
Yes.
Because
There's
we're
a
good.
roll.
The molar mass.
I think that's
Yes.
12.
Yes.
Okay, so,
Yeah, the molar mass of carbon
I
dioxide.
got it wrong.
All right, what is lithium hydroxide's molar mass? 24? 24.
Well, I used 25. That might be it.
All right, and then for every 2 moles of lithium hydroxide that react, 1 mole of CO2 reacts with it and is absorbed. Right, okay, so 1 mole of CO2 is 44 grams.
0.92.
And then you do the math.
0.92.
That's what I got.
That one, like, going from 24 to 25 makes a big difference.
4?
Well, not really.
I use 44, yeah.
I don't think I've ever been too hard on myself.
Okay, so the only thing that made that harder was you had to write the balanced equation from the words now, right?
Is this considered a hard question on the AP exam?
Medium.
I've looked at questions from that thing.
Hey, we're getting our
I
class.
don't even know what it's
You're not there yet. We're
Yeah,
baby
why would
steps.
you
We're
look-
3
when the-
weeks in. Calm
You're
down.
making us jump into a pond and we can't even swim.
Yeah, right. Let's-
Oceans.
That's how you learn how to swim.
Just throw you in?
Oh, God.
It ain't working for y'all.
Threw me into the pool and like, hey, swim.
Hey, swim.
You didn't drown, so you're here. Apparently it worked.
Figure it out.
All right, here's the next one.
Are we done with stuff?
No, this is still stoichiometry. It's just limiting reagent
Oh,
stoichiometry.
Oh, wait, this one.
All right, so what makes this problem oh, my arrow's missing. What makes this problem different from the last problem?
Oh my
There's a
gosh.
lot more.
You're limiting the reagent.
Because I wrote the word limiting reagent up there. Thank you. How do we know it's a limiting reagent problem?
If it asks about the yield,
No, it gives you two.
Doesn't have to.
It gives you two things, like 2 grams.
That's the key. Is it gives you 2 amounts to begin with. Every other problem we've done, we've started with one substance, right? We had 1 gram of lithium hydroxide. We had 1 gram of whatever the first one was, right? But this time we're starting with 42.1 grams of the C6H6 and 73 grams of the Br2. All right, what is the theoretical yield? And we are going to assume that this means they want grams of C6H5. And that's because I looked at the
Yes, it's balanced. Yeah, it is.
Oh, wait, yeah, it is.
Mm-hmm.
I saw the H5 and I was like, this isn't balanced.
All right, so we have a balanced equation. But now instead of just doing one stoichiometry problem, what do we have to do?
2.
We have to do 2 stoichiometry problems. So 42.1 C6H6. So what's 12 times 6 plus 6? 80? Somebody make sure I do my math.
12 times
6 plus 6.
78.
Wait, so what's the
78.
what
I
are you
can't
gonna
add.
You do the same thing, but you have to do it twice.
Yes, you're going to still do a stoichiometry problem. I'm doing nothing different.
Is this when you divide it by the least, or is
No.
that
Isn't it like
That's
the
empirical
largest,
formula.
wait, the smallest number means that's stoichiometry, whatever you started with was the
Yes.
Oh, I remember I figured out a way how to do this.
There are other ways. There are other ways.
Only do one equation.
You can.
Yeah, she tried to teach us that.
You can.
Well, I did it a different way than she.
I was like, I'm perfectly fine with doing 2.
All right, I'm just you. I promise you, I can follow it as long as you write it out. All right, I don't know the molar mass of this. 72, 77. What's bromine? 80, 157. Somebody do the math. Make sure I'm, because I can't do math. So my 12-year-old tells me all the time, you can't do math. We were doing multiplication tables. I did 7 times 5 and told her it was 40. Just keep laughing. She did too. And will never let me
Is
live
she
it
the
down.
one that didn't do vocabulary
And also explicitly refused to take any of your classes.
Yes,
Yeah.
that one.
she refused
Yes.
to
Oh
do
yeah, she
what?
won't be in my class. She's already told me. I'm not taking any of your classes, Mom. I won't be.
Engineering or APQ?
No, I'm not taking your class.
Are you going to make her?
No, I don't care what she take. No, she won't make APQ. All right, is that number right? Somebody check me. Is that
Where's-
number right? Bromine's over there. 80.
72 plus 6 plus, where's BR? Oh gosh.
Wait, where?
72 plus 5.
You get 84 something.
Oh, 5.
Plus.
7.
So
I got
77 plus
157.
80. Okay, that's okay. So I did my math in my head right. Just checking. All right, y'all gotta do the rest of the math for me. I don't have a calculator.
Do we do the same thing, just another number?
Yeah, just with the other substance.
I don't remember. Isn't there an equation for the yield stuff?
Oh, percent yield, yeah, but that's part B. We're still doing A.
It's like a
What's the
percent.
number up here when somebody gets the math done?
84.7.
And then this, everything's 1 to 1, right?
Yeah.
Kid you not, I put C6H6 for the entire stoichiometry.
Mm-hmm. All right, somebody's got to do the next math.
Wait, is it BR? It is BR2.
All right, anybody punch in the numbers on the calculator? I guess I could have done it on my phone by now. I'm like, I could have done it myself by now.
It's just so much to write. It's like
I got 71.6. But you might want to check.
got 71.6.
Okay. All right. So there are 2 stoichiometry problems. Yielded those 2 answers. Which one's the right answer? Which one is the theoretical yield?
And it's
73. No, the second one.
The
77.
second one. This is all it can make. Why?
because the
Because
least
that's
of the
the
two.
least amount.
You'll run out of that one before you
Yeah,
can get
I'm
it.
going to run out of the BR2. So this is my limiting reagent. You know, I can only make as much sandwiches as I have bread. If I have a whole jar of peanut butter, when I run out of bread, I'm done making sandwiches, right? So in this case, I'm going to run out of BR2 when I make this much of the product, when I make 71.6 grams. So although I have enough of the benzene, the C6H6, although I have enough of that to make 84.7 grams, I'm not going to be able to because the bromine's going to run out, right? That's what limiting reagent means. One of the reagents is going to run out before the other one. And if you do 2 stoichiometry problems and you get to the end, the one that makes the least amount of product is the limiting reagent that will run out first. The other one is labeled the excess reagent.
But we're not finding that. Like, I mean, we found it, but to go to get the
Not yet.
yield thingy.
All right. So this is the theoretical yield. That is how much the reaction is supposed to produce. That's what theoretical yield means. That's how much it's supposed to produce.
Nothing is perfect.
But nothing is perfect. No reaction is perfect. And it says that if the actual yield, in other words, they went and did it in the lab and they only got 63.6 grams. So they want to know what the percent yield was. Well, percent yield,
Is actual over
yes, is actual yield over theoretical yield times 100. So the actual yield was 63.6 grams. And what we should have gotten if it was a perfect reaction is the 71.6. So divide those. And what do we end up with?
88.
88 what? 0.8%. So that's our percent yield. All right, how can I make that problem one step harder?
Wait.
Oh, sorry.
You can say how much of the
Of the excess reagent is left over. So we'll add a C to ours. And our C question will be, how much excess reagent, reactant, same word, is left over?
How would you find that?
Yeah, how would we find that?
Would you subtract?
Oh, I think Miss Bennett did it different than I do it.
You subtract and then multiply by something.
Oh, I don't do it that way. I don't like it that way.
Probably didn't understand.
Let me teach it to you the way I do it because I think you'll understand conceptually better. I'm not saying what you did last year is wrong. It is not. But I think you'll have a better understanding of what the things mean. Let me teach it this way. If this is the limiting reagent, then I need to know how much of the excess reagent reacts with all of that, right? Because if I know how much of this that I use to react
Would
with,
you go from grams of that to moles of the excess
Mhm.
to grams of the
Mhm.
excess?
and then subtract from what you started with. That's how I make it make sense to me. So what it is I start with the limiting reagent, and I'm going to do a stoichiometry problem. What? Do you need that? Do you need that?
Oh, you start with the 73.
I'm going to start with the limiting reagent, and then my question basically is how much C6H6 reacted with that 73 grams of Br2. It's just another stoichiometry problem, right? So how many grams of the other one? Okay, so this was 160. Well, what's the relationship between the Br2 and the other? I gotta flip back. Right, it's still 1 to 1. For every 1 mole of Br2 that reacts, I have to have 1 mole of C6H6 react, right? Now, I know you can do this in your head. I'm just writing it all up. What did I do wrong?
You put 11.
No,
You put the
C6H6
on.
I put the wrong substance on the
Shame
bottom.
on you, Ms.
Yeah.
Robinson.
Hey, at least we caught it. You don't ever let me get through with a mistake if you see one. One year I had kids and I got all the way through the problem and they're like, you messed up there. Well, you could have told me a little earlier than now. So we did the whole problem with the wrong thing. All right, so for every 1 mole of bromine that reacts, 1 mole of benzene reacts. And so for every mole of benzene, what's the molar mass of this? 78. Okay, so do the math. So 73 times 78 divided by 160.
35.5875. So
38.6.
35 point. Wait, what?
Oh, 35 point what?
58.
So 6. Okay, I said it wrong, but I was rounding that. All right. Okay, this number means what?
That's how much reacts.
Right, this
How much
is
can
how much C6H6 will react if it's 100% completion, right? How much did you have of the C6H6 to begin with?
7.
41.
Oh, wait.
42.
That 42.1. So I had 42.1 grams of the C6H6. I used up 35.6 grams of it. So how much is left over?
Let's
Mhm.
do some basic math, you guys.
Mm-hmm.
Let's go back to
7 point something. 6 point something.
6.5.
6.5. I typed in the wrong number at first.
So that's how much is left over.
I get all the math. I just don't get what
When it's given in words, that throws
Yeah, I don't know what everything means.
Okay, what do you mean by everything?
So what's the theoretical yield? I don't get how that's what will happen.
Theoretical yield, they just asked it a different way. Theoretical yield is just how much of this will I make. Theoretically. In other words, if the reaction goes to 100% completion, and that's all the stoichiometry you've done. You've assumed that 100% of it converted. Okay, so theoretical yield is just means it's the answer to the stoichiometry problem. So how many grams, that could have read how many grams of C6H5Br will you make if you start with this and that.
Okay, and then the third one, what's the third that accepts C?
how much excess reagent is left over. All right, well, when we did 2 stoichiometry problems, we realized that BR2 is going to be the one to run out. Do you see that? All right, so if it runs out first, it's the limiting reagent. So the other one must be in excess. I must have more than I need. So the question's asking, how much extra do I have? So to figure out how much is left over, how much is extra, I have to figure out how much actually reacts. So that's what this stoichiometry problem does. It figures out how much C6H6 reacts with all 73 grams of the BR2.
Could you technically go from grams, like the 71.6 that theoretically, or are we going on the theoretical yield or the actual yield?
Theoretical.
So could you technically go from like that 71.6 grams to
Yes.
to the
Yes. Yes, you could take that number and just convert to the C6H6, and that would be how much C6H6 you used. Yes. But you'd still have to subtract. You can, people want to subtract these 2 numbers and be done. You can subtract those 2 numbers, but you're not done. You'd have to convert that subtraction then to C6H6, which I don't like because but I think that's how she showed you to do it. Did she?
I don't know.
You subtracted to start with.
Yeah, you subtracted these 2 numbers and then
Yes,
converted to the excess reagent. I just don't like it because I don't think you really understand what it means. But
Like we were just told.
it works. I mean, mathematically it will work, and it will work every time. So I don't really care how you do it.
Can you start with the C6H6 on step C instead of the BR2?
No.
So you have to start with
Well, you could. If you started with that one, though, what you would figure out is how much. No, that would be more. You'd have to do 2 you wouldn't want to do that.
So you have to start with the limit.
I mean, I'm not saying you can't get there that way. You could, but it's too many steps. You'll have to do too many steps. I always, my steps for that is to start with the limiting reagent, and then I convert or do stoichiometry, right, to the excess reagent, and that equals how much was used up. And then I subtract that amount that was used up from the original amount of the excess reagent. That's what I do in my head.
In your head?
Not in my head, but I mean, that's the steps. No. Obviously, I can't do math in my head. I've already messed it up. But anyway, that's kind of the process in my head that I'm going through, I guess, as I do the problem. Okay. Yep, start with your limiting reagent, do a stoichiometry problem to your excess reagent. That will give you how much of the excess reagent got used. And then subtract that amount from the original amount of excess reagent. Jeez! Why does your class go so fast?
I wish we had this first
We
block.
need 2 blocks. We didn't even get to the hard stuff.
Eighth block is the longest block.
We didn't even get to combustion analysis.
Was that for?
That's the new stuff.
Oh, we can say that for next time.
Yeah, well, I don't know if you can finish this, because this has combustion, or this, the Master in Chem. It's got combustion analysis on it.
This is pretty easy.
Lord.
Please, Colin.
Yeah, what we did before was nothing but review. I didn't teach you anything today.
Yeah.
This is new.
Nothing I did today was new to you.
No, it was all.
No,
But
But it's
nothing.
we were taught better.
This, however, is new.
No, I remember this. We did this last year.
Really?
Yes, that's why it's called review.
This you
We
did
didn't
last year?
We didn't do this.
Mm,
I don't
I
see that
remember-
picture.
I remember doing that.
combustion.
Because
Oh,
I
yeah,
remember
I
we had something that reacted with oxygen and created carbon
Oh, if you had an odd, you had to double everything? Or am I just...
Yeah, you do for the balancing, but here's the problem.
That
I
was
know.
all one.
Like I remembered doing.
I'm going to do it anyway.
How you said that first word?
All right, we've got what? How many minutes do I truly have?
Like
8.
no
8?
6.
I can do it in 8.
That's enough to do like 3
6.
lessons.
6?
6.
Okay, I'm going to go really fast. Okay, we're not going to even explain how the thing works. We're going to look at the problem. All right, isopropyl alcohol, soda's rubbing alcohol, is composed of carbon, hydrogen, and oxygen. Combustion of isopropyl alcohol produces this much carbon dioxide and this much water. Determine the empirical formula of isopropyl alcohol. All right, think about what that says. Isopropyl alcohol has C, H, and O, but we have no earthly idea what these numbers are down here, right? Because I don't know what isopropyl alcohol is, do you?
Mm-mm.
Okay, that's the point, is that we're not supposed to know what it is yet. All right, it's combusted. Combusted means that it reacts with oxygen, and it produces carbon dioxide and water, right? They reacted. I'm just simplifying the word problem into simple stuff, or so you can kind of digest the problem. We started out with 0.255 grams of the alcohol, and when we burned it in air, we ended up with 0.561 grams of CO2, and we ended up with 0.306 grams of water. We're okay there? All right, to find an empirical formula, I have to be able to get to moles or grams of carbon, grams of hydrogen, and grams of oxygen. So I can change them to moles and then divide by the smallest, right? How from this information am I going to get to grams of carbon, grams of hydrogen, and grams of oxygen? What's your thought?
Maybe you could go from the 0.561 grams of carbon dioxide
To get to the carbon, right. All of the carbon that's in this isopropyl alcohol had to go to that carbon dioxide because that's the only place carbon shows up on the right?
Mhm.
All right, so 0.561 grams of carbon dioxide, and it will change that to moles. So 44 grams is the molar mass of carbon dioxide. But then we don't have a balanced equation, but we're not worried about the relationship between carbon dioxide and something else. We're worried about the relationship between the carbon in the carbon dioxide. So how many carbons are in one carbon dioxide? One. So for every 1 mole of carbon dioxide, I have 1 mole of carbon. And then for every mole of carbon, it weighs 12 grams. All right, so we can do the math there. That will give us grams of carbon. Grams of hydrogen is going to come from the water because the only place on the product side where the hydrogen is in the water, right? So 0.306 grams of water. 18 is the molar mass, so we're going to change it to moles. And then we're doing the same thing. In water, how many moles of H's for every 1 mole of H2O? 2. So for every 1 mole of H2O, we have 2 moles of H's. And then the H weighs 1 gram. That will give you your grams of hydrogen. We can't do that for oxygen because it shows up in both places, right? We could do it twice
Why
and
don't you
add them.
take what you get from grams and subtract it from both of them?
Sure. We know how much we started with, right? So we can subtract these two. We can add these 2 grams up, right? And whatever we get there, we can subtract from the 0.255 grams, and then that will give us grams of oxygen. Agree? That's the hardest part. Now that we've got grams of oxygen, grams of hydrogen, and grams of carbon, now it's just changed to moles and then divide by the smallest, right?
Oh.
It's just an empirical formula now. Okay? So other than I don't have, other than I don't have the math written, do you follow it?
Uh-huh.
Okay, good. Then you have to do your homework. What?
No, I don't.
I bet. What, Mark?
Oh.
So you get these two.
You get those 2 and then you add those together.
Yeah, you would add the carbon and the hydrogen together and then subtract it from the
I was thinking
total.
it differently. You subtract like the grams of carbon from CO2, like the 0.561, and then from hydrogen from H2O, and then add those together.
Oh, same thing.
Oh, okay. It's gonna get the.
Those should be the same thing.
Dude, what now you add what together?
Oh, no, it's not because you can't do that because we're adding oxygen from the air. So that total over here for oxygen would be both. We need just the oxygen in the isopropyl alcohol. So no, you can't do it that way. Yes.
Do you divide by the smallest number before you convert it all to small?
No, has to be in moles before, because your subscripts for an empirical formula are mole related. They're mole relationships. So you have to be in moles and divide by the smallest number of moles. You have to be in moles.
And that would give you the subscripts for CH and
Yes.
CH.
Yes. Yes. All right, good. Y'all picked up on that fast. Jalen's looking at me like you're nuts.
Yeah,